Hello, fellow iPadders, and hopefully at least a couple of people from my class. I decided to do my video on curve sketching. So I'm going to graph the rational function f of x equals x squared over 3 minus x. It's going to be awesome, so let's get started. All right, the first thing I'm going to do is show you the answer. The answer is not the important thing, getting the answer is the hard part. So I'm going to break this video up into 5 pieces. One is going to be doing the pre-calculus stuff, so finding the intercept and the asymptotes. The second is going to be taking the first derivative and then finding the critical points. The third is going to be finding what I call the pips. In this case, we don't have pips, potential inflection points. But if we did, this would be how we would find them. Fourth, I'm going to make a sign chart. And then finally, I'm going to graph the function. So my dream is that I'll be able to break this up into chapters on YouTube, and you'll be able to go to each one of the chapters depending on what you want to see. If you want to see the whole thing, though, just stay tuned. So if you were in my class last semester, you know that we spent a lot of time graphing rational functions. So we have a lot of tricks in our tool belt already. So let's start by finding the intercepts, the x and y intercepts. Finding the y-intercepts are easier than finding the x-intercepts because to find the y-intercepts, you just set x equal to 0. So I will take f of 0, which is 0 squared over 3 minus 0. And that's just 0. So the point 0, 0 is an intercept. So I'll just make a note of that up here. We have a point on our graph, 0, 0. And that's actually going to be our only intercept because not only is it a y-intercept because x equals to 0, but it's an x-intercept because y equals to 0. And it's the only place where the numerator of our function, that x squared, is 0. So this is our only intercept. Next, we're going to find the asymptotes. Now, to find the asymptotes, your first job is to make sure that the rational function is completely factored. And in this case, it is. So we're just going to set 3 minus x equal to 0, so that 3 equals x. So x equals 3 is a vertical asymptote for us. That's just where the denominator equals 0. So that's not so bad either. Next, because the degree of the numerator is 2 and the degree of the denominator is 1, the numerator's degree is 1 greater than the degree of the denominator. So we're going to have what's called a slant asymptote. And to find that slant asymptote, we're going to have to set up some polynomial long division. So let's go ahead and do that. And I'm going to make sure my x term is first. So negative x plus 3 is going into x squared. And the question is, what do I need to multiply negative x by to get x squared? Well, that's another negative x. So this becomes x squared minus 3x. And then I'm going to subtract. So this will actually give me a positive 3x, and there's nothing to bring down. So we'll do the same thing again. What do I need to multiply negative x by to get positive 3x? And that's just a negative 3. So this becomes 3x minus 9. And we'll subtract, so we'll get 9 as a remainder, but our slant asymptote is y equals negative x minus 3. And so now that's all the information I have in box 1. So let's move on to box 2. Okay, I've intentionally written the f of x equals x squared over 3 minus x kind of small because we have to take the first derivative, and for that we're going to need quotient rule. So we remember how to use quotient rule because I say it all the time. It is low, d high, so the derivative of x squared, which is 2x, minus high, d low, so the derivative of 3 minus x, which is negative 1, over low, low, so 3 minus x squared, like so. So let's go ahead and simplify it before we go any further. When I distribute that 2x, I'll get 6x minus 2x squared, and then plus x squared over 3 minus x. And I've already run out of room, so let me shrink this just a little bit. Having infinite whiteboard space is pretty convenient. And then this is going to become 6x minus x squared over 3 minus x quantity squared. Now, critical numbers are where the first derivative is 0 or the first derivative is undefined, but we need it to be in the domain of our original function. So where is f prime of x equal to 0? Well, it's when your numerator is equal to 0. When a fraction is equal to 0, that means the numerator is equal to 0. So 6 minus x times x equals 0. So 6 minus x equals 0, or x equals 0. So 6 equals x, or x equals 0. All right, so those are our two critical numbers. Let's go ahead and take them and put them back in our original function, all the way back in f, not f prime. And so that's going to give us 6 comma negative 12, and 0 comma 0, though we already knew that point was on our graph. So these are our critical points, and that's what's in box 2. I always like to keep my information in a completely separate area, which is why I made that first slide. But, you know, however you want to keep it is fine. Just make sure you don't confuse yourself. So these are your two critical points, 6 comma negative 12 and 0, 0. Next, we're going to try and find our pips, our possible inflection points. So for that, I need to take the second derivative, set it equal to 0, and solve. Now, if you thought the first derivative got a little bit ugly, the second derivative is not going to be your friend. But let's go ahead and start because we are fearless mathematicians. So I'm going to take the second derivative, which means I have to use product rule or quotient rule again. And now I'm also going to have to use a message chain rule. So we're going to get low d high, which is going to give me 6 minus 2x minus high already running out of room. And this is probably going to be our longest line though, so don't worry too much about that. Minus high, d low, so again, chain rule. And chain rule again, we're going to have minus 1 in there. Over low low, which is going to give us 3 minus x to the 4th, like so. Now, notice that in each of our two terms, right, so we have two terms, which is a little bit hard to see. We have our first term here, and then our second term here. All right. And so in each of those two terms, we have a 3 minus x. So we're going to get to cancel it out. So this is going to become 3 minus x times 6 minus 2x minus 6x minus x squared. And then since we canceled out this 3x, we just have this 2. And I'm going to change this sign to a plus rather than add a minus 1. And then that's all over 3 minus x, and now that 3 minus x is cubed, not to the 4th. Okay? So I guess I'm going to have to scroll up just a little bit. Remember, this is our second derivative. Now it's going to do you a mess of good if you just go ahead and simplify this, trust me. So I'm going to FOIL out that first pair. It's going to give me 18 minus 12x, and then plus 2x squared. And then when I distribute this 2, I'll get positive 12x minus 2x squared. And that's still all over 3 minus x cubed. But this is great because now the negative 12x and the positive 12x die a cruel and horrible death, and the 2x squared and the negative 2x squared share that same awful fate. So this just becomes 18 over 3 minus x cubed. All right? And now, because we're looking for pips, we need to look at when this second derivative is 0. And it's never 0 because 18 is never 0. It's almost always 18. We also would consider when the second derivative is undefined, because that could be a pip as well. But in this case, that point is outside of our domain, so we're not going to worry about it. All right. Next, we're going to move on to that sign chart and have a lot of fun. All right, so finally we're ready to make our sign chart. Let's go ahead and draw our chart. And we're going to mark off the x values of our critical points and our pips, though we don't have any pips in this case. And also the x values of our vertical asymptotes, so that's going to give us a 3 as well. All right. And so now we want to know the sign of the first derivative and second derivative. All right. So when x is negative, what's going on with our first derivative? Well, I went ahead and factored the first derivative's numerator just to help us out. We can see that it's going to be a negative times a positive over a positive, so the entire thing is going to end up being negative when x is negative. Now between 0 and 3, its sign's going to change, so it's going to become positive. It'll stay positive until we get to 6, and then it's going to turn back negative. Now, the second derivative is going to be positive up until we get to 3, and then it's going to turn negative. All right, and so now we're ready to sketch our graph. Well, sketch what each piece looks like. So we're decreasing in concave up, so we're going to look like that when x is negative. Between 0 and 3, we are increasing in concave up. Between 3 and 6, we are increasing but concave down. And after 6, we're decreasing in concave down. So we're going to look like this. Okay. So now that all the work's out of the way, we get to do the fun part, which is sketch the graph. And I'm really looking forward to it. We're going to use all of this information to sketch the graph, okay? So let's get started. I'm going to sketch my asymptotes. I have an asymptote x equals 3 and an asymptote negative x equals negative 3. Whew. All right, next I'm going to plot my points. I have 2 points that I know of, the point 0, 0, and the point 6, negative 12. All right, we found those. And finally, I know that I am concave up and decreasing until I get to 0, 0. And then I'm concave up and increasing from then onward. Until I get to my asymptote, when then I become concave down and increasing. Until I get to 6, negative 12. And then I turn around, I'm concave down and decreasing. Like so. So this is my graph. Now, I hope you can see how all of these different steps fit together into a single graph. The problem can feel a bit overwhelming because there are so many little parts, but really it's all easy stuff individually. So don't get overwhelmed. When you get to the exam, take a deep breath in, let it out, and just relax. All right? Good luck on your exam, and good luck in life. Woohoo!